Thanks everybody for joining me today here. To introduce myself, my name is Lars Herrmann. I'm the General Manager for the Hat Enterprise Linux and Hat Enterprise Virtualization product lines. And I'm also responsible for driving the strategy for Red Hat on containers, which, as I'm sure you know by now, second day in, spans everything we do. It is a really, really important day for us today at Red Hat. Just actually a couple hours ago, we announced two important milestones in our journey to delivering containers to the enterprise. We announced the general availability of OpenShift version 3, which is now available to all our customers, as well as we introduced a new offering, Red Hat Atomic Enterprise Platform, which is available in an early access program, and I'm going to talk about it more. To me, it is amazing how much has changed since last year's Red Hat Summit, when Daniel Rieck and I stood on stage over in San Francisco and explained what containers are, how Docker works, and what can be done with it. It is amazing to see how the conversation has changed, how quickly we have made progress as a community, as an industry, and also as Red Hat with our offerings. Now, the purpose of this session today is to give you the overview of a Red Hat strategy, which is fairly broad, so I'm going to cover a lot of stuff. There are lots more container sessions tomorrow and on Friday, so at the end I show a subset of that. We might even have some time at the end of the session for questions, but please also consider the other sessions. All right, to get started, containerization is obviously one of the hot topics, and it lives squarely in what we heard in the keynotes from Jim and Paul. The business needs to differentiate. Differentiation in markets is driven by technology. The differentiation is achieved through the application and the deployment. So the developers are driven by time to market. They're driven by flexibility. What helps me to meet my time to market and build a better app? And of course, they're also driven by the ownership. They want to own the process. They want to own the application. The ops side of the house is fundamentally driven by different goals. The IT side has to manage many different applications. The cost profile matters, the security profile matters, and compliance. And we have seen that tension in the industry forever. Now, interesting with containers, we see both sides of that equation looking at containers to improve how they work and what they do. Let's go a little bit into this. Developers are all about speed. They want to be fast. They want to build a great application, and they don't want to take any prisoners in doing this. So it's about speed. It's about being fast. And as they built this application in the traditional world, when the application was supposed to go into production, sometimes they literally hit a wall. Suddenly, this great application they built that was designed for speed and rapid change now has to fit into a production environment that is not designed for speed, that is designed for scale, for process, for compliance. So there was that tension in that bridge. How can you actually do application delivery so that it extends the pipeline from the developers without IT getting in the way? And by the way, if you look at this picture from the perspective of the ops guy, sometimes it feels to them they're getting attacked by the developers with their push for speed, for flexibility. Now, containers are obviously very helpful in this, and organizations look at containers as one of the key technologies, together with other cloud or virtualization technologies or software-defined infrastructure, to build a better world in which there is greater degrees of autonomy and flexibility, in which manual processes get replaced by greater degrees of automation. Ideally, everything automation. We are now starting to talk about not just DevOps, but we talk about no-ops environments, where everything is automated, just managed based on policy and what enters the pipe. The reality, though, is most organizations, they can debate if they want to go this way or that way. They were concrete shoes of the legacy. They're stuck where they are because the weight of the past and the legacy consumes all the resources, all the cycles, and makes it almost impossible to drive change. So when we think about strategy on containers, one important aspect is that we actually think containers help both in building the future world, the new shiny object world of cloud, social, mobile, big data, but it also helps driving greater efficiency in the legacy deployments that carry all that weight in the enterprise IT. Now, containerization, with all the hype, is obviously seen as the Holy Grail out there for application delivery. And I want to talk a little bit about what is maybe true or not so true about that. But it is about the quest to find the Holy Grail. That's the theme that I picked for this talk. So let's look at what's actually happening. Typically, containerization in the enterprise begins with a development team getting excited about how easy things suddenly are. It is as simple as doing a Docker pull something, Docker run something, and you have a service running on your machine. Wow. It is as simple as building a container on your laptop, copying it over onto a cloud deployment, and just run it there. Wow. There's a lot of success associated with it. And it looks like the Holy Grail because suddenly there's consistency across environments. What works in one place might work in the other place. There's a promise of portability. Because I package my code into a container, it will run everywhere. We'll see if that's true later. And there's also the choice involved. I, the developer, decide what goes into these containers in the first place, which is what I always wanted. Nobody restricts me anymore. Nobody tells me which technologies to use. And of course, the natural conclusion is, given all that success, let's just containerize the entire data center, right? And do all our applications, all our processes in that model. And interesting enough, when we ask customers, in this case, it's a Forrester study. We did a study with Forrester Research together to actually gauge a little bit the state of container adoption in the market. And what we found was very consistent with our views, is that containerization is seen as an application delivery method. It aims at accelerating application delivery. It aims at creating greater flexibility in where and how and what to deploy. But it's also about greater mobility of applications so that you can actually no longer lock an application for its entire life cycle into a particular deployment paradigm. Like when you start things in Amazon Web Services today, you probably end up leaving it there. Getting it off there is really hard. So creating greater portability and flexibility is the goal. The truth, though, is there is a step in between. We try it on our laptop, and we containerize the data center. And that's where we come in with our strategy. So as any quest for the Holy Grail, there will be problems on the way. And they might look like tiny little cute problems, and they might turn out as real, real bad and dangerous. Let's look at what I think an example. And I was thinking a lot, which application should I use as the example here? And I decided I couldn't really find an example that would resonate with everybody. So I thought, let's use the most interesting application in the world. And then I tried to understand, how do I define that? What's the most interesting application in the world? And given that we have a developer theme here, it has to be the application that gets written the most and rewritten the most. And here it is. As a nice side effect, it fits into little black boxes on this slide. So as you can see on this slide, the most interesting application in the world, written in multiple programming languages. There is no intent about a statement about efficiency or readability of programming languages. But as you can see, the promise of containers is whichever language your application is written in, whichever technologies it might use, you end up packaging into these little containers, and you can deploy them on a hybrid cloud fabric, on-premise in the data center, on bare metal or virtualization, or in a private cloud, or out in a public cloud. That's the promise. And that's very much how the developer experiences interacting with containers. The reality, though, is the source code doesn't run. You need something to make it run. And this is where runtimes come into the picture. If you look at the little examples here, a C application depends at least at glibc, maybe other libraries that the developer pulled in. Typically, would have something like bash in your container as well. In order to run things in there. When you enter the container, you can enter commands and diagnose what's going on. You look at a Java stack, you have the same basis underneath. You still have glibc, bash, a bunch of other libraries that didn't fit on the slide, and eventually you get to JRE or OpenJDK or any Java runtime. All these technologies are necessary to run the simple hello world application. So we're not doing anything complicated here. Similarly, if you go over a Node.js application, simple JavaScript code, easy to write, event-based, fancy, but a lot of technology dependencies underneath, a whole stack of libraries that are required to even run the simplest application. And on the right side, then we go into the more interpreted languages, Perl, PHP, that also have some footprint. Now, what is important about this, when we talk about strategy and delivering the benefits of containers, where do these runtimes come from? Because I've heard statements that now that's a container, it doesn't matter what's in the container, you just package it up and it will run everywhere. So it must be magic. It's unicorns bringing us these runtimes, right? No, it's not. It's the good old operating system. The way containers work is they take the operating system, the traditional one as we know it, the red box on the left, that did two things. It enabled the hardware, and it powered the application through the runtimes and libraries that are necessary to run it. Now, these two functions are still there. They're just ending up in two different places. Containers splits the OS into two pieces. It splits into the host OS underneath, running the containers, providing hardware abstraction and infrastructure services to the containers, and the actual content inside the container. Now, as you see, the advantage is you can package different apps with different libraries, different versions. There is a greater degree of flexibility. So that is true. But the dependencies between the runtimes in the container and the underlying host are still there because you still talk about the same operating system. And in addition, we're also seeing now that things get a little bit more complicated. We kind of indicated with these little lines on the right. There are other services that the container consumes other than just a kernel ABI on which the runtime runs, that things that the container just needs to be available on that host, like, for example, a security policy, in order to be operated in the way it was intended. So that is just part of the truth. So when we think containers, we have to factor in what is actually in that container. That matters. Now, here's an example that I pulled from our data. For the runtime components on that chart, you see the little numbers here. How many security errata did Red Hat release for RHEL 7 for these components? RHEL 7 was launched a year ago, almost exactly a year ago. So we look at 1 year. And as you can see, again, there is no statement in this, but the top would be JRE, OpenJDK in this case, with 66 security errata. And other languages still have very, very high numbers here. The exception being Perl, which seems to be a programming language that would produce very secure applications if you can stand the syntax. So what you can imagine, from a developer perspective, we didn't change our source code. It's still the most interesting application in the world, but we had to change dozens of times what goes into these container images just to maintain security. That needs to be part of our strategy. And that is why ops people might be scared by containers, and rightly so. I get the question a lot, I have all this virtual machine sprawl in my enterprise. Can you tell me how is that going to be with container sprawl? And then my response is, it's going to be a lot worse. Because that's the whole point of it. The whole point of containerization is to enable the application teams to make their own decisions as to when they change a container and also what they put in the container within bounds. But just the when drives divergence. So you will end up with lots and lots of different containers, and that complexity needs to be managed, which is consistent with what we see from customers. Again, the Forrester study asking, what are the biggest obstacles and what are you afraid of with containers? The number one concern we get is, how does that affect my security in my environment? And of course, security is a hot topic, we know that, and it's only getting hotter every day with the move to distributed, connected infrastructures and applications distributed across multiple environments. The second challenge really is, I want to skip performance because Shaq is after me in this session talking about performance. The next big problem really is the complexity of managing what's happening in these many containers in distributed infrastructure across multiple and different environments. So we obviously need to solve a number of problems before we can truly adopt containers broadly in the enterprise and deliver the benefits into the organization. Our strategy at Red Hat, and we've said this last year, we still say it this year, we haven't actually changed it, is aimed at delivering the benefits of containers to the enterprise, but also solve the problems. We obviously have to solve the problems, otherwise you cannot adopt it. At the center of the attention for us is the application. Containers are all about the application. The infrastructure technology is a means to an end. It's about enabling the application and the application owners to be more productive, more efficient, and deliver more business value to the enterprise. And I touched on flexibility. It's all about choice. So we cannot have one size fits all for all applications, all environments, all organizations. So we need to enable choice. The key themes that we've identified years ago when we started our container journey, and we have many, many, many years experience with driving building containers. We launched OpenShift 4 years ago, built on Linux containers. And we were working years before that on the foundational technologies in Linux, in RHEL, which landed in RHEL 6 mostly, to even be able to do OpenShift. So the 3 pillars we've identified is trust and security. It is about portability. Containers are potentially very portable, but we have to make them absolutely portable. Otherwise, you cannot run them in the enterprise and know what's going to happen. And then there is a need for integrated solutions that you can just use, that you don't have to put together and figure out. So going through these one by one. On the security side, I already showed my little example, the hello world leading to dozens of changes. Now, in the reality is actually a lot worse. Here you see a study that another company did a couple weeks ago, actually. They looked at I don't want to name it, a public repository of container images, and they looked at the so-called official ones and did an analysis, how many of them have security issues? And it was a stunning, more than 60% of all these images had at least medium priority issues. So the bottom line is consuming container images from a public registry, probably doesn't matter which, is the same as downloading a random piece of software from the internet. It's literally what you do. So in the enterprise, that's probably not going to fly. And organizations will build policy around it. At Red Hat, 3 months ago, we launched Red Hat Container Certification as one part of the solution to that problem, to enable enterprises to consume containerized services and applications and also development tools and frameworks from a trusted source where they know who created the container, where they know what is inside the container, where they have a way to manage the security of that container beyond the point of download, and where they also can have a support promise. This is what we launched to our ISVs. We're now working with hundreds of ISVs on getting their solutions containerized and certified so that they are available to the enterprise for consumption. The natural starting point for that work is developer-related technologies, things you would do in building applications, but we're tapping into the large ecosystem around Red Hat Enterprise Linux and JBoss middleware. Now, what we launched in March is effectively 4 components for the ISVs. There's a container development kit that actually development teams in the ISV environment and now also customer environments can use to develop the containers. They can be submitted to certification as a service that we host in the customer portal, and from there they can be published in a catalog, so they can be listed, or integrated into the Red Hat Container Registry, which is a federated architecture to consume containers for the end customer. So that box checked, launched, partners are working in, so we have a way to get to trusted, supported, and secure containers. The second problem in the security area is isolation. Like any shared infrastructure, you want to make sure that there is no one artifact running on that infrastructure be in a position to affect others. So if one container gets compromised, it should be contained, and it shouldn't have access to any other container or the host. The truth is, out of the box, Linux containers as a kernel capability is not much more secure than a normal process running there. So if you don't trust processes to be multi-tenant, you probably shouldn't trust containers either. We have solved this problem by integrating our container technologies with SE-Linux, military-grade security, hard policy enforcement. And by using SE-Linux, each container is in a separate policy confinement, can therefore not interact with other containers or the host unless explicitly permitted. And we also do the same thing for the shared services that run on the container. You might have noticed, you might have seen this if you looked at RHEL Atomic Host when we launched it in March. We also made available a set of containers that we provide. There's a tools container, for example, that you can use to troubleshoot on Atomic Host what's going on. These things can also be wrapped in their separate security policy. Now, this is consistent with what we did for virtualization years ago, where we used SE-Linux again as part of the KVM hypervisor to secure and isolate the workload in a virtual machine. Now, we see lots of container hosts run in virtual machines, so we get the best of both worlds. We get SE-Linux protecting the virtual machines from each other, as well as the containers separate from each other inside each virtual machines. Same technology, high degree of security and isolation. Box checked. Now, the next problem is, I used the Hello World example because I really thought it was the most interesting application in the world, but maybe I was wrong with that. Almost every real application is not that simple. We talk about multi-container applications. And as you see in this picture, The traditional applications typically have a multi-tier architecture, whatever. Take your web application, you have a web front end, you have some sort of logic engine, and then database, maybe some caching in between. That's the more traditional application architecture. And you would deliver each of these services in a separate container. If you want to run that application, now all these services need to be instantiated, connected to each other, and need to be managed in order for the application to actually deliver the business value. On the right side, you see the modern architecture of cloud-native applications written in microservices. Strong separation of concerns, minimal footprints, which allows the developer to innovate the individual components and services separate from each other at their own pace, but now increases the need for the multi-container capabilities in the platform, because you will end up with a lot more different services and lots of instances of these services. Because the idea in a microservices-centric architecture is you scale horizontally by adding instances, not by adding compute capacity. Now, containers is really great for both application kinds, because we can encapsulate almost anything in a container. So it is suitable for traditional apps, and it is extremely suitable for microservices with the fast startup times we have around containers. But at the same time, we also have different ways to do resource management and scale. We can dynamically adjust the resource management policy for a more traditional application in order to give it more capacity. In a dynamic environment, we can bring up instances of a distributed service on the right side within milliseconds or seconds. Now that said, multi-container in a multi-tenant infrastructure is complex. And in order to run this predictably, reliably, and secure, you need a foundation on which to do this. Otherwise, your container ship is sinking, as you see this ship is about to sink. Now, how do we manage this complexity? It starts with open standards. We have taken a really strong position in the container ecosystem forever on the need for standards. And when we say standards, we're not necessarily talking about paper. When we say standards, we mean something we all agree to, we all use, and we're not fragmenting for no good reason. We were dangerously close at fragmenting until Monday. I'll come back to this. The open standards that we've identified start with the isolation in the kernel, because that's the basis of everything in a containerized infrastructure. If we can rely on the technologies that are used in the kernel to provide these logical execution environments for services or applications are done in a particular way, then we can assume that if it worked in one place, it will work the same way in another place. So this is in a good shape. In the case of Linux containers, we talk about C groups as the resource manager is actually the primary engine for containers. Namespaces help with the isolation by creating this logical environment, and there are multiple namespaces. SE Linux provides the security isolation, as I talked about, but also the host runtime is part of that picture, because it is the host runtime, for example, Docker, that would tell the kernel what to do. If you instantiate a container, it would set up the C groups, resource management, the security policy, and the namespaces, in addition to other things like networking, storage, etc. The second standard is about the format. The format is maybe the most important of all, but it sits on top of the kernel. The format defines how you build a container and then consume it and then run it. If the format is not standardized, we end up repeating all the work to build, to transport, to distribute, to instantiate, to manage multiple times for each format. And there's really no value in doing that. Docker has done a phenomenal job as establishing itself as the de facto format, with lots and lots of containers being out there, lots of people having skilled, and they've also made it very easy. So it was only natural for us to initiate the conversation amongst many industry players. We actually started with Microsoft, Docker, and us to talk about, can we create a governance structure around the format and runtime for containers. And on Monday, the Open Container Project was born under the Linux Foundation, which now has the charter to take code that Docker donated, part of their code base, and lead it into an open governance model, merging with competing ideas about runtimes and formats, so we can actually, as an industry, drive a standard. So that box seems to be on a good path to be checked. The next standard is about orchestration. And there is a part that needs to be standardized, and there's another part that maybe doesn't have to be standardized. It's about multi-container applications. You need a way to tell the platform what are these containers and how do you want to run them? You don't want to manage this individually. You want the technology to do that, the platform. This is where the orchestration engine comes in. That's the role of Kubernetes, for example. In our stack, we made a strategic investment into Kubernetes, an open source project initiated by Google, and we drove Kubernetes into RHEL Atomic Host. Is a critical component in OpenShift 3 that we announced today, and it will also be a critical component in Red Hat Atomic Enterprise platform. So orchestration does two things. It allows you to describe an application as the sum of its pieces. This container image, this resource policy, this container image, this resource policy, that many instances at least, and maybe some proximity data, etc. Over time, we will see more things that we want to describe about these applications. So it's the manifest that a developer writes, and then the orchestration engine can consume that and can translate it into running services, which is the second part. Run the services, but do so across hosts, across clusters of container hosts, including solving technical problems like if you have one service of an application running on one host and another service on another host, obviously they need to be able to talk to each other, so we have to do networking between these services. And as we all know, networking can be really, really hard. So the orchestration engine manages that for us. It establishes network connections. In our case, on OpenShift, Atomic Enterprise, we're driving, based on SDN technology using OVS, we're driving network flows with segregation so that the application only speaks to services it should speak to, not to everybody else's services, to also drive a security requirement in there. So that is important from a standardization point of view. The capabilities of an orchestration engine should become a standard so we are not fragmenting. An application you build here, you can take into a different environment without having to rewrite it. The last but not least, the fourth area that's increasingly getting in the focus as we see more ecosystem emerging around containers is the distribution of containers. Docker comes with a registry implementation of a registry protocol that allows you to search for containers and then consume from that registry, which is actually clever because it enables a publish-subscribe method for distributing software, which is typically a lot more, or can be a lot more efficient than a traditional push. So you put something in a registry, it's therefore available for systems to consume. So the registry becomes your control point as to what is available inside the enterprise, which is a big deal for your security policy. So registry, our vision for registries is the mechanics should be standardized. There's really no point of having 5 different registry protocols, much like almost every other software distribution mechanism today bases on HTTP in some way, or maybe REST. The Docker registry protocol is a great starting point. But then there's what's actually in these registries. And there's 2 kinds of data. There's metadata about the container, what is in there, who built it, file size, which dependencies, remember the layers, how do the layers all work, and then there's the actual bits. And our vision is federated registries can exchange the metadata and point clients at the most efficient location to deliver that. That's what we implemented with the Red Hat Container Registry, where you actually search on the Red Hat Container Registry, but you pull from a registry that the ISV runs and owns. And we're now working to expand this into the on-premise enterprise registry, which will be the role of the satellite product in our portfolio. That's interoperability through standards on a really good path. Now let's talk about integration. Integration brings it all together. First, some guiding principles. When we talk about containers, what makes containers great are 2 principles. One is we describe as atomic. And when we say atomic, what we mean, first and foremost, immutable. And this is true for the application services in the container as well as the infrastructure services. Like RHEL Atomic Host is an immutable operating system on which you run applications. Immutable means if you have many instances of it, they will be all the same. They don't contain individual state. So you can just throw them away and re-instantiate them. And this is literally what we do when you update a RHEL Atomic Host. We actually throw the old one away and put a new one there from a code-based point of view. The second important attribute is lightweight. We want to minimize what goes into these services, into these containers or container hosts, so that we reduce the security footprint. Less patching is better than faster patching. And last but not least, it's about separation of concerns. Containers draw this vertical divide between the host and what goes into the containers. With the minimalization, we can drive a horizontal separation of concern. Every single function in its own container, so we can manage them individually. We can make a change only when it's necessary. And of course, we have to be able to do this at scale, which gets me to the right side. The second key principles in our atomic application architecture is elasticity. And elasticity starts with, you need some dynamic attributes in there, up and down, node add, node remove, service add, service remove. But it is about the cluster becoming the computer. The vision is that a cluster of hosts becomes the computer into which you have a single entrance point, an instance where you say, cluster, deploy this application. I don't care how you do it or where you do it, just do it. And similarly also, services that run on the cluster are not running on every node individually. Like, take a simple example, log files. Log files can be painful because there are so many of them. There's so much log information generated. In a containerized infrastructure, it's even more because log files are created at the host and they're created inside these containers. There needs to be a service that aggregates all these data flows so you have a single point of entrance. So that is part of our vision for Elastic. And last but not least, location awareness is something that's getting increasingly important as you end up deploying services in very different environments, from a public cloud all the way to a bare metal and deployment in a very sensitive, secure environment. Now, across all these principles, there are tasks, capabilities that the platform needs to be able to do, and this is introspection, so we can know what's actually going on. What's inside containers, what's happening, what's the state, what's going on here. We have to be able to manage the lifecycle. If the artifacts are now immutable, we're obviously no longer using the same methods to manage the lifecycle as in patching things or introducing a new version. So the tools change, the workflows change. And we need resiliency. Applications continue to need resiliency. In a distributed architecture, resiliency can be achieved differently, as we've seen with other technologies before. The second thing I already touched on is, it is a design goal for us at Red Hat, actually for you as our customers, to enable containerization to work well for both the more traditional applications as well as the next generation of cloud-native applications and microservices. So we want to enable consistency. If you build your cloud-native apps today in a silo, this application is likely going to be a legacy in 5 years. And the silo in which you built it will be another legacy silo along with it. The only way to escape from that is to build horizontal standardization across different footprints in which whatever you consider your most differentiated application can live very well as you run the other things that are older and maybe less driven by high rate of change. Now, the second aspect that we care about a lot is portability. And portability starts with the platform underneath. Paul talked about it this morning. Portability across different footprints, from bare metal to virtualization to private to public cloud. And simply put, our container offerings, they can run where RHEL runs, which is a lot of choice. We make containers portable across all these environments. In addition, we also make them portable across platform types, starting with RHEL as a general purpose operating system, going to RHEL Atomic Host as a special purpose optimized for the container use case operating system, to RHEL OSP, with which we integrate, coming back to this, to now Red Hat Atomic Enterprise Platform and OpenShift. So portability across platforms means an application that is running in an environment today can be moved into a different platform type. And we actually start to see that this is reality, where customers want to have the flexibility as an application travels through its life cycle, starts with a big business justification, high rate of change, probably calms down for some time, then maybe comes back up, high rate of change, calms down, eventually becomes a legacy that's just there to support the remaining users. You probably want to associate these phases with different ways how you manage that application. Because if you run things in a high-dense virtualization environment, you will have a different cost profile than in a bare metal world. If you run it in a highly integrated and automated environment, such as OpenShift, you can be especially agile, and you can actually drive rapid rate of change, which you probably don't need for all your applications. So this portability for an application to move across platform boundaries is getting increasingly important. Now that said, let's show it in a picture. It's a bit of a busy slide, so I'll walk you through it. At the bottom, we see the footprints. Already talked about this. The next layer is the platforms where, as I said, there's portability across them, but at the same time, each of these platforms have unique attributes as to why you would choose them. You would choose RHEL Atomic Host if you are looking for a building block that you integrate with other things you already have, or you build them yourselves. So you have a standalone container host that you figure out how to cluster and manage. It's great, it's an enterprise-grade, optimized container host. If you want to, you start with a managed cluster. Red Hat, that's what Red Hat Atomic Enterprise Platform does. It delivers a managed cluster of container hosts. If you want to combine this with infrastructure as a service and virtual machines, that's what RHEL OpenStack Platform does. If you want to combine with developer experience and lifecycle automation and a lot of application services, that's what OpenShift does. So lots of choices for different purposes. On top of this, you have the orchestration engine, Kubernetes, that I talked about, that enables the flexibility and the scale by managing the cluster as the computer. And on top of that, you run your containers, which take technologies from the top. So now let's look at how does that work in an enterprise environment. Let's take one example. You have a bunch more users suddenly on one application, so you need to add capacity. What do? You add container hosts, you can deploy more containers, and you handle that load. Let's look at another use case that happens almost every day, a security problem in PHP. We saw the number earlier, it does happen. That means that your containers that are available are compromised. Not compromised yet, but exposed, so they need to be patched. And that means that whatever might be running right now needs to be patched. How do we do that? We use management products. Red Hat drives an ecosystem of partner solutions, but we also drive our own products. This is a screenshot of a session that is actually happening tomorrow morning about container management. It's a screenshot of CloudForms, our cloud management platform. And what you see here is the aggregate of a view on the infrastructure as to how it is defined from a topology point of view. There are container hosts, nodes, there are containers running there, driving services as they are defined in the service catalog. You see the performance characteristics. You see the utilization of the physical resources. CloudForms aggregates data from the infrastructure to the application fabric, all the way into the applications, and allows you to make informed decisions in managing the lifecycle of applications. CloudForms is very strategic. There's a number of summit sessions also about CloudForms. I encourage you to go there because it's increasingly important because it brings the entire Red Hat portfolio together. And now container management being added just adds to the capabilities that CloudForms already has with managing VMware, RHEV, OpenStack, and public cloud environments. So on the management side, we have solutions. Now I talked about agility. Developers want to go fast, and sometimes things get in the way. What we actually find with our customers, the biggest obstacle to agility in IT is actually not a technology problem. It is not a technology problem that in some customer environments it takes days or a week for a developer to get a virtual machine provisioned for him. We all know the virtual machine can be provisioned in minutes. It's an organizational problem of multiple teams having to perform tasks, and until they're all performed, the output isn't generated. Now, containerization creates a fantastic opportunity to overcome this. Because containerization is both providing a better way to automate by introducing standard interfaces and methods that work horizontally across any service, any application. And at the same time, containerization drives a separation of concerns in the stack that creates the ability for autonomy. Separate parts of the organization can make their own choices without depending on other parts, which contributes to a massive increase to agility, if done right. So how does that work? As an industry, we have used as a service words to indicate levels of abstraction. We are pretty familiar, I think, what infrastructure as a service is. You basically expose a virtual hardware resource to your user, customer, and they can do with it whatever they want. So you abstract away all the physical stuff underneath. Platform as a service characterized it. You abstract everything away, all the way up to the runtime and the middleware services that the application code would interact with. Now, we've used these as categories. Lots of services and products are built around this. What we actually see is it doesn't quite work well in the enterprise because PaaS is often seen as too limiting. It takes too much control and flexibility away from me. Infrastructure as a service is not adding enough value. The example I gave you before, the developer had to wait a week for his virtual machine. It's literally just a naked virtual machine. There's nothing useful in it yet. So the developer now, after waiting a week, has to go off and provision whatever, the database in there and configure it and all this. So there's not enough value add. Now containerization creates the opportunity to actually redefine that stack. And it is happening right now. We begin to see that happening. From a technology standpoint, we see that containerization drives an aggregate that is different from the traditional PaaS, where now the application code with all their runtime dependencies becomes a thing. And you can build autonomy around it by handing the ownership of this thing to the application team. With some guardrails and guidelines, you can give them, here are the middleware components you are allowed to use, here's how you have to do security, but you hand over the ownership. They own the change, and they can make the change whenever they want because they sit on a level of abstraction. And the level of abstraction is, in this case, the container fabric that I put somewhere in the middle of this runtime box to indicate that runtimes can be part of the infrastructure ownership or the application ownership. And again, the container fabric, your container hosts, can be abstracted from the underlying physical infrastructure through means like private cloud, OpenStack, or virtualization. So an organization can actually define the organizational structure as well as the ownership, as well as the tools along a flexible line in the technology stack. And this way you can have a team, let's say you have a team that owns the OpenStack private cloud. And what they deliver is an infrastructure as a service, virtualized services of physical assets that applications can consume, but also that container infrastructure can consume. Now you have another team that owns the container infrastructure, and then you have your many application teams. In this model, each of these teams can make changes to what they own without having to coordinate or wait for the other teams to do something with it, because there's abstraction in the stack. We're early with this, but I think it will change the game. And our strategy is to actually make it happen. We've started doing it. Here's an example from the OpenStack roadmap presentation that I think was this morning, showing how Red Hat brings OpenStack and containers together. The way we do this is we actually use OpenStack services to make the container fabric better without reinventing the wheel. We describe this as environment aware. The container fabric, for example, OpenShift, Atomic Enterprise Platform, will be environment aware, meaning when they detect I'm running on top of OpenStack, they will use storage, network, and compute services from OpenStack. If they detect I'm in a public cloud, let's say Google Cloud, they will use Google services. So this is something that technology-wise we drive into Kubernetes, environment-aware container fabric. Similarly, we've already implemented, and we demo it here at the booth, that OpenStack becomes the resource manager that if the container fabric in, let's say, OpenShift, Kubernetes, runs out of steam, needs more capacity, that OpenStack, via a defined heat template, goes off and provisions more container hosts, either in the form of a virtual machine or via Ironic as bare metal hosts. So from a management paradigm point of view, this starts to become one thing, without necessarily becoming all of what we associate with PaaS. It still is a general purpose computing platform where you can define where you put that line of abstraction. This is a net new degree of freedom and will accelerate the innovation in the cloud infrastructure space. Now let's talk about products a little bit. We bring all these capabilities, all the principles I talked about, to market in the form of products. And the point of these products is really to make it consumable for the enterprise, for the customer. So a product means it is supported, it has a release cycle, it has a life cycle. So if you make an investment into this product with skills, with money, with time you put into provision it, you can use that for some time without having to change it all the time. For the container platform space, I really want to talk about 3 offerings, all of them as new as today, or almost as new, and contrast a little bit to articulate the choice that we've built into the system. There are 3 offerings on that slide. Red Hat Atomic Enterprise Platform is a deployment platform for containers targeting the IT ops organization. It's for running and managing containers, wherever they come from. They might come from ISVs in the form of certified containers. They might come from development teams that just use tools outside of that platform to build these containers. The second offering is OpenShift Enterprise, which targets the combination of development and deployment and running and managing of containers in an integrated platform, which has a lot of value. If you can bring these two sides of the house together in a single platform, you can drive a lot of synergy, agility, and productivity. That's what OpenShift stands for. Targets the developers and the ops guys. And I admit it's a bit hard to read here. Red Hat Cloud Suite now takes it up one notch further. Red Hat Cloud Suite for Applications is an offering we announced 3-4 weeks ago at the OpenStack Summit, which is combining the container capabilities of OpenShift Enterprise with the infrastructure as a service capabilities of RHEL OpenStack platform and Red Hat CloudForms as the hybrid cloud manager. Therefore now becoming the platform on which you can run virtual machine-based and container-based applications next to each other, managed through a single pane of glass, which can be traditional applications or cloud-native applications. So it is kind of a greenfield solutions for any applications inside the cloud paradigm. Now, what's common across all these platforms is they deliver the benefits of the container paradigm. They all aim to modernize application delivery for existing things through greater standardization and automation, and at the same time, increase agility by enabling autonomy, flexibility, and ownership. And they all deliver consistency across different environments or different lifecycle stages from development to test to production so that you take a lot of risk out of the system that today you have to manage differently. And last but not least, it builds on the vision of open hybrid cloud, all of them. That's all common. Now, let me talk a bit about the functionality. These products are building on each other. So this is a build-up chart. It starts at the bottom with Red Hat Enterprise Linux 7 and RHEL Atomic Host. That's the basis of all these offerings. And this is how we light up a vast ecosystem of certified hardware, of supported hypervisors, and even public cloud providers. Now, we take these capabilities in the US and turn it into a managed, clustered deployment platform. And this is Atomic Enterprise Platform. Atomic Enterprise Platform allows you to run and orchestrate multi-container applications across a cluster of hosts. Remember the principles I talked about in elastic, service aggregation for log files, cluster management, resiliency. All these capabilities are there for running containers. OpenShift takes it up a notch by adding the technologies and features that are valuable and necessary for the developer or DevOps type organization, starting with the developer user experience, web front-end API, the high degree of automation inside the platform. There's a feature called source to image, which monitors the source code repository for a project and the container images from which it builds. And if it detects a change, automatically builds the new container and can even deploy it if that's what you want. All automatic without anybody doing any manual work. It builds on the application lifecycle management capabilities. And remember my example with the runtimes early on. The lifecycle of a deployed application is driven by a need for change, and that need for change is either in the application itself, in the source code, a new feature that the developer works on, or it is driven by something needs to be fixed in the depending runtime components. So OpenShift makes that very easy, very efficient, and is fully optimized for auto-scale, for scale-out applications, elastic applications. It has auto-scale capabilities so that OpenShift actually manages fully automatically the spinning up and down of instances of services, and it can even suspend and pause services. So it's a very rich, integrated environment. Now, Red Hat Cloud Suite, as I said, adds OpenStack and CloudForms to that picture, and now combines the virtual machine infrastructure as a service paradigm and self-service and software-defined infrastructure around it with the container paradigm. So now an application can consist of VM-based services, like maybe for traditional stateful services like a database, to which microservices in a more elastic paradigm in containers connect, or vice versa, whatever reason you have to spread. At the same time, you can gain the synergies of building a single cloud infrastructure on which you host these different services that you offer to your internal customers. So you offer infrastructure as a service to parts of the organization, fine. You offer more container-based services to another part of the organization, great. You can do it on the same physical resource. You don't have to go into separate silos to do that. You can combine it. And Red Hat Cloud Suite for applications make that possible and makes it manageable. Now, last but not least, on all these platforms, you can deploy certified containers by Red Hat and Red Hat middleware and mobility services. So they are compatible and supported on all these platforms. So these are real choices for building out the infrastructure around containers. From a technology standpoint, it comes down to RHEL atomic hosted bases as the container host. Remember the standards I talked about: isolation, format, runtime, orchestration. The container API is Docker today, and this is what the orchestration engine interfaces with, which is Kubernetes, as I talked about. This is where Red Hat Atomic Enterprise Platform ends. OpenShift 3 goes up one notch to deliver the language, runtimes, middleware services, and application services, and the entire developer and DevOps tools and experience around it. So that's the difference, but you can see that OpenShift Enterprise includes Red Hat Atomic Enterprise Platform, so there's also a seamless path to go from one to another. Now, to wrap it up, today, with having these two offerings announced, we actually checked a few boxes here. We've made enormous progress in enabling trust for the enterprise with certification, with containerized products by Red Hat, with these solutions that you can run very securely. We have increased choices on the portability front, different platform categories running on different environments, and we have reached the next level of integration. There's a session tomorrow, I'm actually going to talk to this in a minute, the container roadmap, which gives you more of a window across the entire Red Hat portfolio, from infrastructure, from RHEL to OpenStack to Atomic to OpenShift to middleware to storage to management products. Everything is up on stage and talking about what are they doing to complete our vision on containerization. With that, we've actually found our Holy Grail without getting lost on the way. And just want to point out these sessions to you, and we actually do have some time left for questions, if there are any. Any questions? There's a question.
So what's the main difference of a container and a VM?
What's the main difference of a container and a VM? To keep it simple, let me answer it in two ways. A container and a virtual machine are conceptually very similar because they both are a logical something. It's very different how they work, though. A virtual machine builds a virtual hardware environment that a container doesn't have. The container is literally just a process that's put into a context. The more fundamental difference is a virtual machine image versus a container image, where the virtual machine image contains a complete operating system environment, and the container image does not. It only contains the runtime components that the application contains. Smaller surface, less problems, greater efficiency, because it doesn't have to support the virtual hardware environment, but at the same time doesn't abstract as well as virtualization. You cannot run a Windows container on a Linux host or vice versa. A container is like a process, yes, that you can deploy as an image. That's a good way to simplify it. All right. Other questions?
I may have missed it. I'm trying to figure out, do I see where Cloudflare is going to possibly integrate quote-unquote container management and RHEV management with OpenStack management all in one?
10:40 tomorrow. All right. Other questions, but it's probably hard to hear. So the question was about where can we see container management, work management together, and the answer was tomorrow morning in the roadmap session. Container management, yep.
Two topics. One, talk a little bit about the scalability concerns
Okay. Yep. Okay. So first question, scale limits, basically, or scale attributes of the infrastructure. Conceptually, the sky is the limit. We know that we are running a very large environment in OpenShift Online with millions of applications. Google is always the poster child with billions of containers every week. From a technology standpoint, right now, to be honest, I haven't seen the deployments yet that are big enough that we have hit limits. We know there will be limits as in any distributed system, which is why we design a architecture where you have kind of multiple layers of scaling out. So Kubernetes is certainly one potential bottleneck at some point in size, but using CloudForms, we can aggregate multiple Kubernetes environments. So right now, I cannot give you hard numbers. I would say in the hundreds, we're okay. As you get higher than that, we'll probably run into issues with network and storage and all this. But we haven't even seen that yet. It's too early to really go into these sizes for general purpose IT, which is a bit different than single purpose HPC grid type environments. Okay? Security, I mean, I talked a lot about what's most important. It's about what's inside the container. We are seeing right now that the lack of digital signatures and therefore the ability to automatically verify content is a bit of an obstacle in many environments. But that's actively worked on, and we'll have that soon. Other than that, the isolation capabilities are there as they are in standard RHEL. So it becomes a trade-off now. The more you tune up your security, the more it tends to get in the way and might break your automation. So I don't think there's any particular massive gap on the security front right now, to be honest. It's probably more the tools to manage the complexity I talked about. Yep. Pretty much, the mechanics are different. You would have to update your container images and then basically redeploy and restart them. So that you would do different things, but the flow is basically the same. The difference, though, is you can actually, because the containers have identities, they kind of have a content label on them, you will have an easier time to actually have that inventory information available, what is actually in which deployed container, and therefore, what do you need to change? So that, I think, you can add a layer of automation. Containers have the potential, it's not baked into product yet, but have the potential to be more efficient in managing the security of patches. Because you get that metadata on the container that helps you to know what's in there, what problems might be in there. And then you can just throw them away. Okay? All right, one more question? So, okay, yeah, so let me repeat it for people still here. So do we certify? Yes, that's what I talked about with container certification. Do we uncertify if a big security issue comes out? We don't revoke certification. We notify partners that there is something important for them to do to basically rebuild the container. And if a customer would call in for support, we will also tell the customer. So the ISV owns the container. We're not changing that. We're looking into automated services as an optional offering, if that's what the ISV wants, so that we rebuild that container, that we could do. But right now, we don't do it because the ISV owns the container, so we cannot do it on his behalf without him telling us to do so. Okay? All right, good. Then thanks, everybody, for your attention.